I see that we have a lot of participation, which is good, and I'm happy that I can host this meeting today. So what are we going to talk about today? So basically, the main focus of this webinar is around the semiconductors. We're going to start with the latest market trends that are shaping the current global semiconductors industry. We're going to be talking a little bit about the projections for the semiconductors in 2023 and beyond. We're going to be spending a little bit of the time in analysis of the key players in the industry and their strategic movements. We're going to touch base on the impact of technological advancements, policy changes, global events on the semiconductor market. And at the last session, and the last time for the session, we're going to be talking about effective strategies for risk mitigation and leverage opportunities in the semiconductor market. Of course, you are free to ask any question anytime. And at the end, we're going to be having a dedicated session for the questions and answers. So let me start, for those of you that are not in the industry, what are exactly the semiconductors? So why the semiconductors are here? So basically, a semiconductor is a material that is used in electrical circuits and that can conduct electricity. So that is a main purpose of the semiconductor. There are different types of the semiconductors. The semiconductors are basically everywhere that we are currently able to see in your smartphones, in your PCs, in your tablets. Everywhere where there is a need for electronics, there must be a semiconductor. There are different types of semiconductors, starting with memory, microprocessors, commodity integrated circuits, so-called ICs, and complex SoCs, system on chip. So for those of you that are in the market, you are perfectly aware about what are exactly the semiconductors. It's just to touch base on the topic and to give a little bit of the insights for those that are not in the topic. So why are we going to be discussing semiconductors today? Why semiconductors are important? Chris Miller, in his book, in his bestseller that is currently available on the world, called Chip War, is saying that the semiconductors currently are world's most critical technology. It's a $1 trillion market, and this whole industry of the semiconductors is expected to reach trillions by 2030. So trillion is 1,000 billion dollars. So that is a huge amount of amounts that we are talking to. Basically, from an industry that is worth $412 billion right now, in 2019, its value has rose to 580 in 2022. So you can see that the growth is visible everywhere. We're going to be talking about it later on. Semiconductors are as well very well known for its fragile and very interconnected supply chain. It has a very highly complex, interconnected nature of manufacturing of the goods. And basically, it makes the one party relying on the another party. So basically, we can say that the semiconductors are all interconnected to each other. So the supply chain of those goods is highly fragile and very specific. Basically, if we're going to be talking a little bit more about the automotive, because that's from where I'm coming from. In automotive, the semiconductors, the amounts of the produced goods is going to be basically doubling by 2030. So in automotive, there is a huge growth that is currently visible in the semiconductors that we are all recognizing by the fact that there are some implications that I'm going to talk about it on this later. So as most of you know, there are different news that are being basically published every day, starting with the fact that US is announcing that they are spending $50 billion to revitalize the US semiconductor industry. They're going to be spending $39 billion in semiconductor incentives already starting now. EU has announced that they are going to be having a $43 billion deal to boost semiconductor production in Europe. Taiwanese chip giant has invested $40 billion in US plants. $19.5 billion are being invested by India, and they are joining currently the race to become #1.
Kamil, this 40 billion from Taiwanese company is on top of what US government is investing?
Yes, that is on top of the currently US subsidies. Yes, that is true. France currently have said that they're going to be spending $3 billion to boost local production, only dedicated in France. Britain, following as well the announcements, has launched $1.2 billion semiconductor plan after US and EU have announced their plans. Very recent news, as you may all hear about, Intel is planning to build 4.6 billion chip plant in Poland, close to Wrocław. This is going to be a back-end assembly. All of those news are being currently distributed, and I think all of you have been hearing about those news. So why semiconductors are so specific? As an example, this news is that Apple, as a major producer of electronics in the world, is making the production to go back to US facilities. So basically, they're trying to shorten their supply chains, and they're trying to make deals with US semiconductor suppliers. This is because they are being subsidized by US government to basically bring back the production in-house. We've all heard that the semiconductors has a great implications on automotive world with a shortage of chips. If you are buying currently a new car, you need to wait a minimum 1 year to get this car manufactured. Those lead times are being extended, and this is all because of the very fragile and interconnected semiconductor supply chain. Because of that, Toyota's sales have fallen nearly 6% only in January of 2023, as they are not able to produce as much as they could because of semiconductors. Semiconductor is currently one of the biggest supply chain risks in Asia, accordingly to the local agencies. Currently, we all know that there is a huge inflation of the world. One of the reasons for inflations in automotive specifically is that the fact that basically the semiconductors are driving the huge inflation costs for automotive industry. And there are huge effects currently on this automotive industry when we talk about what shortage has been doing on those on the market. Nearly $210 billion is a revenue that has been lost by automobile manufacturers in 2021. Average lead time has been extended from 3 to 4 months to 12 months and even above currently. Nearly 18.3 million vehicles has been cut down from their production schedules in 2021 and 22 because of the lack of the semiconductors. So that's why it's very important to understand what market are we talking here about and why. So I'm pretty sure that all of you have heard those news. So now I'm going to talk a little bit of why it happened and what are the next steps. So as you can see, what are the next steps? If you look on the semiconductor total addressable market that has been presented by one of the biggest companies in the semiconductor industry, which is NXP, in 2000, it all started with laptops, desktops, mobiles. In 2005, there started to be a new revolution with game consoles, home audio, hi-fi. With the demand being growing exponentially, with smartphones, data servers from the period of 2010 to 2020, there is a still steep growth of the overall addressable market for the semiconductors. If you look on the next new technologies like 5G, like AI, like autonomous driving and machine learning, all of those new innovations are going to be boosting the semiconductors demand in the future. If you look on the publicly available information that is published by the biggest semiconductor companies, you can see that in 2021, the total available market growth was $590 billion. In 2030, it's gonna be a double of that amount, nearly a double, with a growth, the biggest growth factor in automotive electronics and industrial electronics. On automotive, there are two mega trends that are currently driving those demand up. First one is electrification, and second one is basically autonomous driving. With industrial electronics, the factor driving it is machine learning, artificial intelligence. And as you can see, currently the growth contribution is huge. So automotive by 2030 is gonna be a 20% market for the overall industry of semiconductors, having the very high influence on the overall situation. All the semiconductor companies are preparing for growth right now. So that's why you can see those huge investments being basically announced and currently ongoing. I will talk about it more in a second. My focus and my area of expertise is related with automotive. So when we talk about automotive, you can see that the figures are being increased expansionally with a focus on two factors, as I said before. Advanced driver assistance systems, which is the so-called autonomous driving, and electrification. ADAS is going to be basically tripling the amount of automotive semiconductor market, and electrification is going to be doubling from what we see in 2025 to where we will be in 2030. There is a huge growth in front of us, and all the companies are starting to realize this fact and trying to prepare in advance their supply chain and prepare their strategies to respond with that growth. If you look on the semiconductor distribution in the average car, it has changed and will be changed dramatically. It has changed in the past and will be changed in the future. If you look on 2023, majority of the current vehicle is related with microcontrollers, so MCU. The next part is communication and infotainment, ADAS, small portion of electrification, and other board components. But the car of the future will be consisting of nearly 50% of ADAS and electrification, with MCU being still high but lowering. But of course, the communication and infotainment is going to be a factor that will be dropping in the percentage-wise of the vehicle. As I said, the in-vehicle content of semiconductors is increasing expansionally. At the same time, those two mega trends, electrification and autonomous driving, are still increasing the need. So we're going to be only seeing the situation being worsened than it is today, or maybe not. So maybe I will try to answer the questions later on. In order to understand the semiconductors, you need to understand very important factor. There is a different semiconductor that is needed for the consumer electronics needs and a different for automotive. When you talk about the process technology, the technology that is currently used in consumer market is between 28 to 3 nanometers, while in automotive, the market is still using the old technologies from 180 to 7 nanometers. The same applies to the temperatures and the operational factors of the semiconductor. The requirements from the consumer are the device needs to be operational in 0 to 40 degrees Celsius, but in automotive, the standard is that it needs to operate in all the conditions. So from minus 40 to plus 120 degrees Celsius. In this PC market or the consumer electronics market, the operational lifetime is between 3 to 5 years, and that's where the producers are giving the guarantee. But in automotive, the component itself needs to withstand minimum 15 years of service and operation. There is a tolerated failure rate on the customer parts, which is below 1,000 parts per million. But if we look on the quality of the automotive industry, there is zero defect that is being currently accepted by the producers. So basically 0 parts per billion can be faulty. And if you look on the supply chain perspective, you don't need to have a long-term supply for customer goods that you can buy from the catalog. But in automotive, you need to really prepare and have a long-term supply agreement with your vendors to be prepared upfront. So right now, what are the key players of semiconductors automotive industry? Starting with Infineon. Infineon has grown in 2022 by 27%, being currently #1 in automotive, followed by NXP, STMicro, Texas, and Renesas, with a total market growth being all-time high last year. If you look on the Texas Instruments forecast, you can see that the number of units shipped is going to be increased exponentially, and by 2028, it's going to be nearly 130 billion parts that they are going to be shipping, which at the level currently, they are at around 90. So with that 90 level, they are already on the, we are all in the shortage industry, right? So what is going to happen next? How companies are going to be basically preparing for that growth. That's why we see all of that high investment happening in the market. If you look on the Renesas presentation, they are preparing currently for the huge market growth, with the total addressable market for them from 2019 to 2029, a growth nearly about 3 times. With the global light vehicle production being increased by around 10%, but the content per vehicle is going to be increased nearly 2-fold. The same applies to STMicro, where they are basically...
Sorry, just one question. The previous slide, it's about Renesas or it's about Texas?
So you have 4 suppliers currently on the screen.
Okay, my mistake.
Yeah, so the top left is Infineon, top right is TI, bottom right is Renesas, and bottom left is ST. All of that information is publicly available. It's available on the investors presentation. So I really encourage you, if you would like to have more details about what those companies are actually forecasting for next 10 years, all of that information is available in the investor presentation. I just took the ones that are basically showing the growth and showing the projections of the market. Okay. So now, how are we prepared for that? Are we prepared as buyers? Are we prepared as a category managers to respond to that growth? So,
Kamil, if I may, on the previous chart, there is a market growth, but will you cover also how do those companies are preparing themselves for the growth, or what's the link between market growth and investment of those companies?
Sure. So basically, all of those companies currently have announced a big investments. Infineon is investing in Europe, TI is investing in US, STMicro is investing in Europe and US at the same time, and Renesas is investing in Asia still. So all of those companies have announced an investments that are currently preparing them to respond to that growth. But at the same time, suppliers are basically leveraging the fact that there is a big time seller market still. So at the same time, they are still trying to use that into their advantage. You know, it's a simple law of economics that when the demand is not fulfilling the supply, the prices needs to go up, right? That's a simple rule. So basically, the supply is limited currently. It will be better in the next short-term period, within 1 to 2 years, but still, all of those suppliers are enjoying the fact that there is not enough capacity for them. At the same time, they are preparing themselves to respond to that growth, and all of those suppliers are making investments to fulfill the growth. But all of them are at the same time having the same concern: are they not gonna overinvest? So that's the decision that they need to make, of course. Okay, but now talking a little bit more about the policy changes and the impact to the industry. Accenture has surveyed all of the big companies that are currently buying semiconductors, and they've asked them, what, in your opinion, are the biggest challenges for the semiconductor supply chain today? So 35% of the respondents have said that the inflation and economic concerns with the prices being up is one of the major factors that is influencing currently the supply chain. 20% have still said that there is a COVID-19 impact that has been happening, and they are still recovering out of this impact. 18% have said that there is not enough talent to fulfill the pipeline to support the growth. 14% have said that still the companies and the investments that have been announced is still not enough. And 12% have raised the geopolitics concerns. I'm going to talk about it in a second. So the next question that they have asked is, what are the factors with the greatest impact on the semiconductor innovation in the next year? So basically, one of the impact is ecosystem considerations, like chip sovereignty and geopolitics. So geopolitics is a very important factor, because if you have a semiconductor that you have already designed in with that semiconductor, it's very hard to resource. At the same time, the cybersecurity still remains a big question mark on how companies are going to respond to that. And the third factor was a changing competitive landscape. So basically, fact that all the companies have built a huge inventory currently, and they are trying to remove that inventory by buying at a cheaper price, but at the same time, it's a risk that all the companies are making with them. Talking more about the geopolitics in the semiconductor industry. If you look on the figure number 1, when the design, where the design is created basically. So currently 65% of the semiconductors is being designed in the US, with 17% in Taiwan and the remaining 15% in China. When we talk about the fabrication, there are 2 steps of how to fabricate the semiconductor. First step is the front-end assembly, and the second step is a back-end assembly. When we talk about fabrication, we are talking here about the front-end assembly. So this is where the highest technology is, and this is where you need to have a huge investments to support the growth, and this is where the know-how is. On the fabrication side, Taiwan is leading with 60% of production worldwide of the semiconductors, followed by South Korea, with 19%, and Samsung mainly, and 8% of US. The rest is only a small portion. And when we talk about assembly, all those assembly is located mainly in Asia. So mainly in Taiwan and China. So those are the 2 countries that are making the assembly. So all the recent Intel investment announcement that has been made is about the fabrication being done in Germany and assembly being done in Poland. So basically front end Germany and back end in Poland.
When those plants could be operational?
So in semiconductors, if you look on the greenfield investment in semiconductors, it takes about 3 to 4 years from nothing for the plant to become operational. So that is a minimum time that is required to build a new fab and start to produce semiconductors. there are different concerns like energy, for example, that are absolutely needed and energy supply for the semiconductor manufacturer. So, but normally it's between 3 to 4 years. When you look on the next page, I'm talking here about what is happening next. If the current silicon is not enough, what is next? What are the new technologies that can fulfill the growth? So basically, Infineon, with the recent investor presentations in second quarter of 2023, have announced that the next big step in semiconductor development is gonna be silicon carbide and gallium nitride solutions. So gallium nitride ability physically is more than 1,000 times more efficient than silicon. So basically it can help applications like adapter changing, server, solar applications, and onboard charger to support the growth and to support the needs and to minimize the size and of course to maximize the output. So potentially Infineon believes that by 2027 the market of the new applications is gonna be basically around $6 billion. If you look on the chart on the right, silicon, the current silicon that is being produced in the charger, is gonna be completely changed to the gallium nitride solution by 2030, with the server following and the onboard charging as well. The same happens with the low power motor control and residential solar. So Infineon believes still that this is the next step in the industry.
Does it mean that this gallium nitride technology will free capacity on the current one, silicon carbide?
Yes. This process requires completely different manufacturing and would mean a different supply chain as well for the producers. Yeah, that's true.
But the difference between silicon carbide and gallium nitride, is it about the raw material, the base of the front end, or about processes of this chemical printing?
It's both. There is a physical difference and at the same time the manufacturing difference. So at the same time, in the future for those applications, Infineon believes that the current silicon is not going to be enough to fulfill the needs. So basically, the production is going to be switched to the new technologies. So that's what there are both physical difference on the part itself. At the same time, there is a difference in manufacturing.
Mm-hmm. Okay.
So with all of that and all of that mix, we need to answer a question: what are the effective buying risk mitigation strategies that are currently in the market? So as I said, over the last 3 years, companies have experienced a seller's market. So semiconductor companies have experienced a seller's market, which is on their benefit because at the same time they can still increase the prices and keep the production output with allocation at the steady level. So how, as the buyers, we can overcome the situation? How can we enable a successful buying strategy? My view on this is that, first of all, we should sign a long-term agreements with key vendors with a dedicated capacity reservation. So that capacity reservation should be dedicated to your company needs, so that whenever the new crisis comes, you are protected and you have your dedicated capacity booked at the vendor, which has its disadvantages, but at the same time, you should be identifying the top components, and for those top components, really have a dedicated capacity.
Sorry to interrupt. Do you really mean capacity as capacity, or you mean rather an allocation? Because that's where I my short experience is telling me I no longer speak about really capacity, because capacity means really going to the process and so on. And at least suppliers that I am working with, I have to work with, none of them is able to sign any long-term agreements. They rather expect a full liability agreement. I mean, yes, okay, dear customer, we can have an agreement, but not something which is open, like we know it in the automotive. Yeah, every company having a contract with Volkswagen has no guarantee Volkswagen will buy 1 million if 1 million is in the forecast. We don't know what it's going to be. Our semiconductor manufacturers are asking clearly kind of binding quantities. And that's the challenge.
Yes. So first of all, my view on the whole situation is that OEMs have started already to realize the situation that they are in, and they have started to realize the fact with having fixed commitments to the tier ones and to the other manufacturers. With that, you can transfer the same commitment or make a step ahead and really proactively book a capacity at the dedicated vendor. So I've seen a lot of different capacity reservation agreements that suppliers, of course, not for free, but with a dedicated fee, are willing to sign with customers. And with that, you would be able to secure a capacity dedicated for you, for your company, and for the OEM.
So it's taking the risk on your own.
At the same time, yes, but at the same time, you need to make sure that the OEMs are as well participating in at least portion of the cost, or at least participating in a risk mitigation strategy. So they are taking the liability. At the end, it's a question of who takes a liability. Right now, the semiconductor suppliers are not willing to take any liability. At the same time, tier ones are not willing to take any liability. So all the responsibility is on the OEM side. But there is a different view on how OEMs are handling it. And there are different ways. But my view is that if you don't have a dedicated capacity reservation agreement, you will be not successful in the future, as the next wave of the shortage, in my view, is coming in 2025. And this wave of the shortage is basically gonna be the same or similar to the ones that have happened in 2020, as there is still a big need overall on the market for the semiconductors, and there is still not enough capacity to produce.
Why would you expect a similar shortage? I mean, I understand there might be some correction on the market, but I find I can hardly believe we can go through the same shock as we had during pandemic, because then the conditions on the market this would need to happen again, something which we had. I don't know what your guys' experience was, but I think we had basically the same, all of us, most of us being as a tier one. Mm-hmm. So we had from one day to another, we had all call-offs from our OEM customers disappear. And there was a total panic, right? So we all tried the same with semiconductor suppliers. They tried to kill all the contracts, all obligations, all liability to the subcontractors. And I think right now, no company in the supply chain can go to such an extreme actions.
Mm-hmm. The reason why I believe that there is going to be a shortage, next wave of shortage, is simple. The current situation of allocation for semiconductor vendors is a good thing for them. They can still imply and apply a cost pressure on the whole supply chain, and they will be still successful because they know what are the implications. So that's my view. So
So, Kamil, basically what you are saying, if I understood it correctly, it will be more like speculation on the supply side. Suppliers, they will try to play with the market.
Yes, yes, that's my view. That they are enjoying an allocation market, and they will continue this.
Okay, so I think in this case, the shock on the market won't be to the same extent like it was during the COVID. Not the same scale, I think.
Well, it can be because of the overall capacity. It can be because of the growth. There is a still huge growth, and still not enough capacity to fulfill that growth.
Okay.
Well, I think just like you said, it will be rather the strategy policy to extend the current state of status quo to that they are the winners. Yeah, that they can dictate prices, that they are and that they are always creating this feeling that demand is higher than the supply.
Correct.
And as long as it is somehow manageable for all of us, that we can manage our demand, our forecast, I mean, still something I can imagine that we can live with. If I compare what was 2 years ago, 1 year ago, that was I cannot imagine this to happen again. But if we are in something which is manageable, which is predictable, then still something we can live with.
Yeah, for me, it's simple. The companies that are not preparing for the shift will lose. That's my view. So my view is, without a dedicated long-term supply agreement with a capacity reservation, the suppliers will, the manufacturers, the end manufacturers will use that to their advantage. That's my view. Okay. So how you can basically be ahead of the curve? First of all, of course, using the latest technology nodes. All the investment that is happening on the latest technology nodes. Old technology nodes that are specifically used in automotive industry are currently not invested on. So there will be a pressure from OEMs and there will be a pressure from suppliers to change to the latest technology, to make sure that there is a capacity over there. As all the investment and all the money comes from the consumer market, and this market is already ahead of automotive. So,
but we know why. I mean, that also what you said at the beginning, that in other branches, the products are exchanging every 2 years, especially in the cell phone industry. We are talking about business which takes, I don't know, 6-7 years, and then you are obliged to secure another 15 years of deliveries. So that's different.
So without redesign loops, you will not be able to do it. That's my view. There needs to be a redesign loop in the life cycle of the product. Next point, in my view, is watching the market and adjusting the needs. With that said, so we've seen very recently that the demand overall is a little bit dropping. That is causing the prices to stabilize. At the same time, if you see right now that the prices are being stabilized, I would suggest that you still buy the components, because I think that the prices are not going to be, and never going to go down to the levels before, and they will be only increasing, because at the end of the day, someone needs to pay for the investment, and the manufacturers will be still using that to invest.
So it's like physical hedging.
Yes, yes. So it's a physical hedge. Yes, correct. The next point, it's easy to say. I know that it's hard to do in the automotive industry. It's to ensure that the dual sourcing is there. There is a high cost associated with having 2 suppliers or at minimum 2 fabrication sites qualified. At the same time, the dual sourcing is something that is really that the industry starts to use, and there's even a pressure from the OEM to make sure that the supply chain is really robust and stable. At the same time, having the resiliency plans in place. What happens if there is an earthquake tomorrow in Japan? What happens if any other natural disaster happens? So all those plans are currently being made, and with so fragile, interconnected supply chain of semiconductors, those things are really strictly connected to each other and should be taken into account when implementing a successful buying strategy.
So coming back to this dual sourcing, if we can exchange maybe some kind of lessons learned or kind of concept, because for me dual sourcing means a second supplier. I mean, it would be very easy to take a definition of what is dual sourcing. It could be the same manufacturer producing in a different location, but this happens quite rarely. Maybe it will happen more and more, but right now it's quite rarely. But normally you would expect a different manufacturer. If it's a different manufacturer, then it's difficult. If you are lucky for some minor components, it's pin-to-pin compatible. Maybe the delta validation is also minor, but for these, let's say the high concern components, they are usually not so easy to be replaced. You would have to change the architecture of the product. You have to go through the new design. Development. So it's money, it's time, it's resources, and even resources is critical in the development teams.
So all of that is at the end a matter of cost. What is the opportunity cost that you can gain out of the dual sourcing, and what is the potential loss that you can have when when there is an earthquake at specific fabrication? So all of that is dependent, and what is the revenue risk that you currently will be having with, let's say you are only dependent on one supplier, one fabrication site. What is the revenue risk that you are having with that specific component that is impacting your business? That is the question that every company should be answering, and with that, you are able to assess if the validation cost of the second supplier, the software implications, the resources problem, all of that is taken into account. That's my view. You need to assess the opportunity cost in your business case calculation and think about it broader. If there will be a perfect life, what would I do?
Mm-hmm. So it's like business continuity planning in this case.
Yes.
For semiconductors.
Yes, it's strictly connected to this point. Yes, correct. So with a robust supply chain and with a business continuity plan for every component, you can use that to your commercial leverage negotiations at the same time. Yeah?
I mean, it's if you read it, okay, it's understood. It's if you try go down to the details and how to do it, then it becomes tricky. Yeah. And I can confirm our customers, OEMs now, some of them are being more proactive, talking to the manufacturers, trying to understand that this business, because especially European customers had no idea about how it worked. Some of them still don't. But if they create a checklist of more and more requirements from tier ones, and now business continuity plan really comes on that list. I still have a white card in front of me, because I'm still not sure how to manage. If I think about what happened 2-3 years ago, when it was like all stated rather as a kind of something we could not influence, because I could, in my small area, I could do really everything possible. Still, in the end, I'm not an island here, and it was a global issue, and how to protect my company, my business from something similar, I cannot imagine. We can of course create some small steps, some small actions, but I don't think they will be really giving us the confidence.
Yeah, but for example, there are different ways. You can build up an inventory of the finished good. You can build up an inventory of the raw material. There are different ways on how you can manage the situation. All of that is, as I said, strictly connected to the robust supply chain resiliency plan. And if you have a supply chain resiliency plan in place, you can always use that to your advantage when negotiating with semiconductor supplier. That's my view.
I have another perspective that's from electronic industry, one of the global players, a very well-known global brand. And I participated in a discussion with their CPO, and actually they told me those days we are implementing very simple tools. We do not think about anything sophisticated. And the simple tool that we implement to protect us and to protect our customers is to buy more than we need. And he said, we are ready to invest. We don't care. It costs us much more than before. It's investment. Of course, there might be a risk because maybe customers, they will not come to us with their new demand, but that's what we are doing.
Yes, exactly. And at the end of the day, you need to assess your revenue risk that is associated with the fact that one diode is missing, that is costing, I don't know, 1 cent, and you cannot build the whole product because of this. Or at the end, if you will buy for, I don't know, 3 months production of this diode or 6 months of production, and what is the risk that is associated with that decision. So at the end of the day, somebody needs to pay for it because there is no such a thing as free lunch. But there is a different situation on different company. In automotive, it's very specific that usually the OEM is having measures to protect themselves. Yeah. So that's my view. So with that, I think we can go ahead to the Q&As. We had some very good discussion already, but maybe we still have, I think, 10 minutes left. So maybe there are any different questions.
I mean, I'm still with this to-do list. What we should do, what we can afford, and what we can get paid for, because yeah, we are discussing it broadly. Okay, there's a one OEM coming and saying, do you want a new program? Okay, you have to sign a contract and confirm you will have a 6-month safety stock. Okay, in theory possible as long as there will be enough semiconductors on the market, but then you have to afford it, you have to pay it. Okay, the customer will pay 1, 2, 3, 5% on top, but it's not about 3, 4, 5% on top. It's about millions or tens of millions or hundreds of millions of dollars frozen in the warehouse. You know, there's what we said, liability or credibility of the demand. Maybe one customer is quite stable about their demand. Some others are not that stable, and if you are only getting 50% of what you expected, but you have to place order for the next 12 months, then it's a big burden. Also, what we mentioned, the price increases. The price increases were very extreme, and there was a take it or leave it. So a lot of friendships were gone in such discussions. And I don't know what the experience of other participants is, but are we getting what we are? Are we getting this compensated from OEMs? I don't think so. All these price increases that we had to swallow from semiconductor manufacturers.
Yeah, so that's why you mentioned important fact from the buying side, right? it's very important to ensure really to evaluate a risk. If the risk is too high to handle the revenue, then the company needs to make different decisions. But from my perspective, the most important is really to ensure that whenever you can, right, is to make sure that there is really a strategy on how to protect that risk. It can be either A, via dual sourcing, or B, continuity plan, or C, discussion with the customer, right? So that you can do it even without a discussion with the customer. There are ways on what you can control.
I think that there is even another question one step before. Can we answer ourselves how much it will cost us if there is no semiconductor available for a particular customer? How much it will cost us? How big impact it will have on the if we won't deliver to the client?
Maybe I can add my few cents.
Product. Sorry?
Maybe I can add a few cents. I'm not buying semiconductors anymore, but I used to be in this electronics business for some years in my previous company, right? And this crisis, it's nothing new. What is happening today? I mean, this cyclical pattern, because it started, as I remember, 2018 with all the trade wars. So we struggle a lot also with the semiconductors. And when you ask about decision making, yeah, we were cooperating a lot, of course, also for some components with the brokers, and you know how big margin brokers are putting this on the price of the components, and you know that in the crisis they make millions or even billions. So what we developed, and all the respect to our category managers in my previous company, we had a very nice strategy for the semiconductors, including the planned phase outs of the individual components from each of the manufacturers. We had a roadmap of the planned launches of the new products with a very also short life cycle, few years only. So it was managed well. We had a plan which new supplier for which component will replace which one, etc. And we had an also decision-making pattern. So, for example, when we had this allocation, and we had an offer for a broker, for example, you can buy this or that. We have that quantity, and yeah, we knew that we can use it. We were calculating basically the impact. So, how much money it will cost extra? What is the risk for production stoppage? What does it mean? What would it mean for a factory? I mean, in terms of the people, in terms of the shifts, and eventually, what will be the loss of the margin if we are not able to deliver to the customer? And it was prepared by the purchasing and sent according to some approval thresholds to the main stakeholders within the corporation. And by doing so, we were making decisions. Of course, there were always questions: why does it cost so much? But at least there was a decision making that all the important guys in the company, senior management, they had to make a decision. Okay, does it make sense to buy that amount of components extra, pay hundreds of thousands extra, but for example, I don't know, compromise this relationship with that customer? That's one thing. And second thing, why my previous company won, but it will be, of course, very trivial statement, but it was the case really. Why that company won the market over diverse competitor? It was because of the relationships. So of course, in the allocation, it is that maybe you will not get 100% of your plant demand, but at least you will get something, or you will get more than your competitor. Right. And at that time, my previous company really won the market over the other competitors because they had good relationships for the semiconductors. But of course, this world has two ends. I remember for the LED diodes as a company that was really cost optimization obsessive. We also had, I would say, ruined relationship with an LED supplier, where our CEOs were flying to that company to Korea, and it was pushing so much for the price reduction every year that the relationship kind of broken. So I would say every company has its own backyard, but relationship matters. So even if you do not get 100%, the question is, am I getting more than my competitor, for example?
Yeah, am I able to win the market over competitor?
Yeah, so you mentioned very good point at the beginning related with the cost study, right? So to understand what is it worth, right? Is it worth better for me to really buy those goods in advance, or is it better for me to not to do it, right? So that's kind of a decision based on the business continuity plan, right? On the figures.
Absolutely right.
And then the second point you mentioned is relationship with suppliers. Of course, it's very important that, and at the same time, unfortunately, bigger players can do more. Yeah, so always the small players are thrown into the corner, and always the big players have the bigger bargaining power over the small.
That's why we rather started to call it not relations, but kind of visibility. Yeah. Especially buying through distributors, we were confronted with the fact that we had no visibility with some manufacturers, and we had no power, no leverage to get our shares. But one more thing for me, I don't know what was before 2019, 2020, but every manufacturer told me that, like, these old guys saying, I'm from the beginning of this industry, and I have never been through something like now, so there was no crisis like this. But what for me was really difficult to manage was the escalation process going to OEM, and when you realize that actually your share was maybe not stolen, but was reallocated from the top, from the OEM, because the OEM decided that maybe some safety brake system is more important than the infotainment, and your escalation is a farce because they know they are taking these components somewhere else. But still blaming you and taking you to lead all these escalations, three-party calls and actions.
Yeah. Fully agree. There are cases that the OEMs are driving the allocation, and that's connected to the fact that they have the power. They have the power to influence, and they have the volume, and they can really decide what is good for them, right? So at the end of the day, if you have a signed contract that is defining rules and responsibilities between two parties, you can always refer back to that signed contract, and you can always refer back to that fact. So that's my view, that there should be a really capacity reservation agreement in place that you can always refer back to, you know, in that situations.
Okay, thank you, Kamil. I think our time is over. Discussion was really good. There were many questions during your presentation, so thank you for doing it for us. What I would like really encourage all of you who joined the webinar, please watch our website. We'll be publishing information about follow-up to this one. So let's watch how the situation will be changing. In case you might have questions related to this difficult market, please also do not hesitate to contact us, and whenever it's only possible, we'll try to support.
Yeah, thank you very much.
Thank you very much.
Thank you. Have a good afternoon, I think, for...
Yeah, and let's have no crisis in 2025.
Yes.
Thank you.
Thank you.
Thank you.
Thank you so much. Thank you.
Bye-bye.
Thank you.